I'm going to explain Unit 7, which is exponents. I'm going to explain how to do a few problems to show my knowledge about this topic. Well, the first problem is negative 5 over 2 in parentheses to a power of negative 3 times 5 to a power of 0. Well, to solve this problem, the first step, 5 to a power of 0 is 1, so it will be times 1, so we cancel it out. It doesn't matter. And well, the next step. We see that it's to a power of negative 3, so that means what's inside the brackets will flip. So you will end up with 2 over negative 5 to a power of positive 3. After that, you have to put 2 to a power of 3 and negative 5 to a power of 3. Then, well, the answer is 2 to a power of 3 is 8, and negative 5 to a power of 3 is negative 25. Negative 125. And that's the final answer. Okay. Well, in this problem, we can observe, first of all, that we can have the same basis here. So we can change this to simplify it. So the lower part would be negative 2 in brackets to a power of 3, which is negative 8, times x to a power of 3. So now it has the same basis up here. Well, here, since the 3 is outside the brackets, we have to multiply. We have to power it to both integers, both numbers, not just 1. So 2 to a power of 3, x to a power of 3. And well, from here we can see that it's x3 on both sides, so we can cancel it. And we can also cancel this 2 and 3, so we get to negative 1. That's the final answer. Well, in this next problem, it's 27 to a power of x equals 3 to a power of 7 times 9 to a power of 9. So what we first have to do here is make all bases equal. So well, we can see 3 to a power of 3 equals 27. So we simplify it to 3 to a power of 3, or to a power of x. Well, here it's already 3, so we keep it the same. And here it's a 9, so it's 3 to a power of 2. Times 3 inside brackets. Power of 2 to a power of 9. Well, now that we have the same base, we have to multiply these numbers, because it's outside the parentheses. So we get 3 to a power of 3x equals 3 to a power of 7 times 3 to a power of 18. Well, now that we have the same base, we can cancel them, and the only thing that matters is what's up. So we're left with 3x equals 7 times 18. It's a times sign, but since there is a law of exponents that states that if they have the same base, you have to add them. So technically it's 3x equals 25, because you have to add them. And finally, you divide everything by 3, and you get the answer. X equals 25 over 3. This problem is similar to the last one, but the only difference is that we have a radical sign. When we have a radical sign, it's the same thing as saying to a power of 1/2. So, well, here we're also trying to find the common base in order to solve it. So, 3 to a power of 1 times 27 to a power of 1/2. Now we get rid of the radical, equals 9 to a power of 2x. Now we can make everything the same base. Well, 3 to a 1 times 27, which is 3 to a power of 3 to the power of 1/2 equals 3 to a power of 2 to a power of 2x. Now we have to put everything together. From 3 to a 1 stays the same, times 3 times 1/2, which is 3/2. So 3 to the power of 3/2 equals 2 times 2x, which equals 4x. So 3 to a power of 4x. Now we have the same base, we can cancel it. We're left with 1 times 3/2 equals 4x. Well, here the same law applies as in the last question, because we have a multiplication sign, but we have to add because it has the same basis. We're going to add 1 plus 3/2, which is 5/2. So we're left with 5/2 equals 4x. To get rid of the denominator, we have to multiply this side by 2. So we're left with 5 equals 8x. And well, to get the answer, you divide everything by 8, and you get 5 over 8. Well, this problem is 2 to a power of 6 minus x is equal to 4 to a power of 2 plus x. Well, this problem we also have to find the common base, which is logically 2. So we have to reduce 4 to 2. So, well, 2 to a power of 6 minus x is equal to 4, which is 2 to a power of 2. times 2, well, to a power of 2 plus x. Now to put it all together is when we have to multiply, so it stays the same. 2 to a power of 6 minus x equals 2 times 2, which is 4, and 2 times x, which is 2x, 4 plus 2x. Now we have the same base, we can get rid of it. We're left with 6 minus x equals 4 plus 2x. So we just have to solve for x. So we do plus x, so we're left with 6 equals 4 plus 3x, minus 4, 2 equals 3x, and divide everything by 3, x equals 2/3. Okay, well, these are exponential growth equations, and well, you have 5 formulas: exponential growth, half-life decay, compound interest, continuously compound interest, and continuous growth or decay. Well, you just have word problems, and you have to decide which equation to use in order to solve the problem. So when you decide the case, decide the equation, and you just have to substitute, well, plug in for the variables and solve for what the question is asking. So, for example, AT was the total, AO is the initial investment, T is the time in years, rate is R is the rate, and N is the amount of times compound yearly. So all the variables are the same for all equations except for K. In half-life decay, K is half-life, and in continuous growth or decay, K is the rate. So that's the only case that the variables are different. So basically, you just have to know which variable is which, know how to plug it in correctly, and you can solve these questions easily. Well, this is Unit 9, logarithms. Well, this is the log. Some facts about it is that the log always has base 10. It didn't have any base, but if it doesn't say anything, it's definitely base 10. It's the inverse of an exponent. And, well, ln and e are inverses as well. And well, there are some laws that I will show you how to solve problems with those laws.